Hey friends, it's time for another episode of Rust from the Beginning. This time we'll talk about functions. First off, when it comes to functions, why do we have a function? We have a function because we're interested in having a set of statements that we can reuse. So instead of just copy-pasting those statements all over our code, we take those statements and we group them under a named reference. For example, in this case, I've taken a bunch of statements, I put those inside of here, I've created my named reference with the fn keyword, the name of my function, opening and closing parentheses, opening and closing of curly braces. Then I can later in my code reuse like so. So here on line 5, I'm invoking my function using the open and closing parentheses, ending with a semicolon. So that's the basic, that's the idea of functions. So let's look at various types of functions. Here what we're looking at is a log function that does a print line and it prints out log. That's all it does. Let's try to compile that program. Once the program has compiled, we can run it and we can see that we get a log out. Now, looking at the log function like this, if the only thing it does is to print the log like so, it's not very useful, right? So what we ideally want to do is to send across a message, and we can use string, can call from, and then send across the message hi. But at this point we need a way to receive this message. So what we do is to say we add a parameter like so. And we also want to interpolate, meaning we want to mix the two. So we're doing like that. So now what we're doing is ensuring that log here is being prepended, and then comes our actual message. Let's compile and run. And now you can see how we can do log hi, or we can say, for example, function started, or whatever you want to do as your log message. Functions are great. Sometimes it's perfectly fine not to have parameters like this, but most of the times I would say a function has a parameter. Let's compile that as well so it reflects what we just did. So now you can see that we can reuse this log function, and it's quite nice, right? So all we need to do to change this log function in the future, if we want maybe something to happen after, we can type that here, maybe a date. It's very common, for example, with the log function that it starts with log like so, and then the actual message, and then maybe a date time stamp or whatever you want, right? So you have a log function, take that as a take-home exercise and try to improve it. Now, I've already mentioned parameters. You saw how I added a parameter, and you saw how I added a type. So I just want to re-emphasize that. That is how you would work with a function. So let's take this function and let's call it add. In this case, I'm going to use, no, we're going to call it divide, right? We're going to do first and then second, and we will divide these two. Now we have a problem at this point because we are trying to return the result, but we have no way declared that the function should actually return something. And the way we do that is by adding this arrow here, and we're looking at what types we have coming in, and we see that the return type should be a float 32 as well. So now we can run this, and you can see that our editor is helping us typing what we should be typing. And because we're taking a float, we're doing as float 32, and we do the same here as float 32. Now we're not really printing this. We should, like so, with a print line. And now let's try to compile that. So now you see that we get response 5, which is exactly what we expect from a division function. So what was new here was the fact that we added a return type with this arrow and a type, but also that we repeated this concept of if we want a parameter, we need to start with the name, colon, the type, and any new parameters can be added with a comma. So that's how you would keep building on this function. Now, there's a thing here that we've shown you so far, and this is a statement. And what makes it a statement is the fact that it ends with a semicolon. Now, Rust offers a different way to return values from a function by you not returning a statement, but rather an expression. And to make it an expression, we remove the semicolon, we remove the return statement, and this would still work. To prove that it still works, let's compile this. And you see, I still get that response back. So the benefit of doing it this way is that if you have the last line here as part of a function, if you make it an expression, Rust will see that as you trying to return. Now you can call a function within another function. That's also worth showing. So in this case, we could, for example, say we can use our log message or log function, and we can say string from, like so. And this is a way for us to keep track on the fact that we are calling other things. So now you see that we're also logging as we are entering a function, and we could, what I've shown you so far is how you could be creating functions for operations where you feel like, hey, I'm gonna do this in many different places. We saw with the log function how good it was that we could just create a log function so we can prepend or add whatever we want and wrap that message in a nice little wrapper. We could make it reusable by adding a parameter. You saw also when I created a divide function how we could introduce multiple parameters but also add a return type, and also how we could be really efficient when it comes to returning a value by skipping the return keyword, skipping that semicolon, and just return when it looks like so. And yes, lastly, I showed you how you can just call a function from within another function. So you not only have to call functions from main, but you can call them from anywhere. What we can quickly do at this point is to keep building out this example. So we have ourselves a calculator. So we have divide, let's do add, let's do subtract, and multiply. Now, starting with the add method, it needs to work a little bit different. I don't think we need to deal with floats at this point, so we change that. Unless, of course, that's what you want to send in. That really depends on the contract, right? When you're trying to say how should this function work. So here we do a plus. Now for our subtract, let's make that integer as well. And calling subtract. We do a minus at this point. And multiply, first, second, yes. Let's change this message. And let's do I32. Like so, and then change that. Now that we created all these methods, we can take them for a ride. We've already done divide, so we can copy this 1, 3, 4. If we do multiply here, you can see that it's not really a fan of us typing it like so. So we do 10 and 2. Now we're multiplying 10 by 2. We don't need to do any conversions. Division, that's not what we're doing. We do subtract. And let's do 10 and 2 here as well. Which one haven't we done? Multiply, subtract, add is the one missing. Let's do 10 and 2. There. And now you can see how we get different results depending on what function that we are calling. So if we call division or divide at this point, 10 divided by 2 is 5. Multiply 10 and 2, you get 20. Subtract 2 from 10, we get 8. And adding 10 plus 2, we get 12. So we can see that our calculator program is working. we are definitely on a very good path to using functions, using parameters, and understanding how we could return values in different ways. That was all for this video, but stay tuned. If you like this video, please consider subscribing. That gives me a signal that I will create more videos like this. Thank you so much for watching.